Hello, today I'm going to tell you about RC series circuit connected to a sinusoidal voltage source. So here we have a resistor 1.35 kilo ohms, a capacitor of capacitance 1 microfarad will be connected to a generator giving me a sinusoidal voltage of a frequency 100 Hz. So this is how to connect our circuit. It is very simple. The capacitor to the positive and the minus to the resistor with here like that. And now we should connect the oscilloscope in order to observe both the voltage of the generator and the voltage of the resistor. Why? Because our goal is to compare the voltage of the generator with the current flowing in the circuit, and since the voltage across the resistor is proportional to the current, so we measure these two voltages. Now this is the common ground point. We will connect it here because we need to measure the voltages of these two components. Then we put the ground between these two. Channel A is connected to the positive of the generator, so remember, channel A will measure the voltage of the generator and the channel B will measure the voltage of the resistance. Now our circuit is ready. This is the oscilloscope and we can do this experiment, and the two oscillograms are very clear on the screen. We can expand it, and now I want to make some measurements to reach some goals. First, my first goal is to see if they are in phase or not. It is very clear that they are not in phase. So the current and the voltage of the generator are not in phase, but so one of them leads the other, or one of them lags behind the other. So which one does lead the other? It is very simple. For example, take this vertical line which represents a certain instant. At this instant, what happens? The lower voltage reaches its maximum, where the higher one is still going to reach its maximum. It does not reach its maximum here, so the lower one leads it. The lower one leads the second one, the higher one. Now, in order to know which voltage does this one represent, it is very simple. Since this is the smaller, so it is the voltage of the resistance, because the voltage of the generator is the higher in the circuit. And also you can, since you know that channel B measures the voltage of the resistor, you can put here 0. So you know from 0 which one is the voltage of channel B, so it is the lower one. Thus you conclude that this one leads the other, so UR leads UG, or finally I leads UG. This is the important conclusion. Now I wrote these here, so first conclusion is UR leads UG implies I leads UG. Second, I want to calculate the difference in phase between these two oscillograms. Also, it is very simple. I can write here, to calculate phi, which is the phase difference, t, the period, represents 2 pi, as you know, since the period represents for me a complete cycle. So t represents 2 pi, but f equals 100 Hertz and t equals 1 over f, so it is 1 over 100, which is 0.01 second, or 10 milliseconds. This is the period. Thus, if since the period is 10 milliseconds, this means that 10 milliseconds represents 2 pi radians for sure. And now, going back to the oscillograms, we see that here the difference between, let me say, the difference between this one and that one is given in this value T2 minus T1, it is 1.25 milliseconds. This is the difference between the two oscillograms. So we write 1.25 milliseconds represents phi, and 10 milliseconds represents 2 pi. So phi must be 1.25 times 2 pi over 10. And 2.5 over 10 is 1 over 4. It is known, so phi is pi by 4 radians. This is how to calculate the difference in phase between the two oscillograms, keeping in mind that any circuit containing C and R, thus I in the circuit, the current in the circuit, must lead the voltage of the generator. And now, going to achieve another goal is to assume that C is an unknown capacitor and we want to calculate it from the oscillograms. So assume that C is unknown and given I is Im cosine omega t. This is an important point in any problem like this. One of the two, I or UG, must be given before. So in this case, I want to give you I, and then I want to calculate UG. So UG must be equal UM cosine omega t minus phi. Why minus phi? Because as we said before, I leads UG. So if the phase of I is omega t, and it leads UG, so UG must be omega t minus pi by 4. It lags behind I by pi by 4. So now, what is UM? Going to the oscillogram, this is UM, it is given by 2 and channel A. 2 channel A, it is 9.87, which I will write 9.9 approximately. Before this, I can say UG equals UM cosine omega t minus pi by 4, where omega equals 2 pi f, it is 200 pi, since f is 100 hertz. And now, UM is 9.9 volts as we see before. And what's about UR max? UR max is very simple. It is the voltage read by 1 for channel B. 1 channel B, it is 6.52 volts. So I wrote it here. UR maximum is 6.5 volts. Now I can deduce I maximum. It is UR max over R, which is 6.5 over 1350, because the R is 1.35 kilo ohms. Thus, I maximum is 0.0048 amperes. And now I can write the expression of UR and UG and UC, because I have three voltages of U generator, U resistor, and U capacitor. What is UR? It is R times I. We have to multiply this one by 1350. It gives us 6.5 cosine omega t. What is UG? It is 9.9 cosine omega t minus pi by 4. And what is UC? You have to know that I is equal to dq over dt, which is C duc over dt. Thus UC is the integral, or 1 over C, the integral of I dt. This is the expression. So 1 over C is the same. Integral of I dt, how to integrate this expression? Im becomes outside the integration because it is a constant. So it is Im over C integral of cosine omega t. What is the integral of cosine omega t? It is 1 over omega sine omega t. So I will be, UC will be Im over C omega sine omega t. Now I have the three voltages, so I can use the law of addition of voltages in order to get C, the value of C. So UG by the law of addition of voltages is given by UR plus UC, implies that 9.9 U cosine omega t minus pi by 4, which is UG, equal to 6.72 cosine omega t, which is, 6.5 cosine omega t, which is UR, plus Im over C omega sine omega t. The final step is to take a certain value for t. Any value of t is true, but we have to not to choose the value where t equals 0. Why? Because if we choose it, then sine 0 is 0, so we lose c. And we have here two equal values, which is true for every value of t. So we choose another value of t. Let me use omega t to be pi by 2. Why? Because in this case, I can get rid of this term because cosine pi by 2 becomes 0. So I get two terms only. So by replacing omega t by pi by 2, I have 9.9 cosine pi by 2 minus pi by 4 is pi by 4 equals 0 plus I am over c omega times sine pi by 2, which is 1, so I have I am over c omega. So c is I am over this number multiplied by omega. I am is 0.0048 over I multiply 9.9 times cosine pi by 4, which is root 2 over 2, times 200 pi, which is omega, so I get 1400 pi. By dividing these two numbers, you get 1.09 times 10 negative 6 farad, which is very close to the real value given for C.